This is Dr. Holt. In this video I want to add vectors A plus B plus C plus D together. And I'm going to go ahead and show these as a vector here. Well, that's fine. Should have little arrows on top of this so we know these are vectors here. Okay, so we're going to add these vectors together here. First we will start with A. A is in the second quadrant. Now if you're confused at all about this, I'm going to recommend you do this. Draw an arrow that's very similar to this one. So I'll come down here, I'm going to clone this, move it into place. So this will help you to decide which way the components are going to go. Start from here at the tail, draw either a horizontal this way, and get it so it lines up almost with this, then come back to this one. Okay? Or you can start here at the tail and go vertical. It doesn't make a bit of difference. And then go this way. The reason I'm doing this is going to help you tell what's going to be positive or negative. Now since this goes up, we're letting anything that goes this direction up to be positive, anything to go down be negative, anything that goes to the right to be positive, anything that goes to the left to be negative. So if we look at this, we will have positive and negative here. So we'll just start right now of defining the components of A. Alright, if you're confused, this is a 6 degree. Go ahead and show your 6 degree in your picture here. Like this. Okay, this component here is opposite of the 60 degree. So this opposite over the hypotenuse is equal to the sine of this angle here. So you could say that, we'll call this the AX component. You can say AX over the hypotenuse, which has a magnitude of 50, is equal to the sine of 60. So then you can say that AX is equal to 50 newtons times the sine of 60. I'll run that number real quick. 50 times the sine of 60 gives me a value of 43.3. So I'll come down here, I'll put 43.30. But again, it's going negative, so we make it negative here. Okay. Now, if the angles are ever given, coming from all the way over to here, coming from the positive x-axis all the way counterclockwise, so you hit, take the time to find out what this reference angle is here, the closest, and then base all your trig calculations off of that one. But again, if the angles come off vertical, you're going to use sine here to find the horizontal component. Alright, so now we'll do comma. Then we know that we're looking for this one here, which is the same as this one here. So this is adjacent, so this we will use the cosine. So again, we could say that AY over 50 newtons is equal to the cosine of 60. Or we could say AY is equal to 50 newtons times the cosine of 60. So 50 times the cosine of 60, that gives me 25 newtons. I should have put newtons in here too. So that is A written in the component form. Now we come to B. We do the same thing here. Again, if you're confused at all about the directions, just go ahead and draw yourself another arrow out here. Draw from the tail over till it's even here. We go up, and we can tell right now positive and positive. Here and here. Alright, we come down to B. We draw the components, and again we can draw this is our 35. Again, I'm going into a lot more detail, but if you need this, that's fine. If I'm looking for this, component, this component over this adjacent over the hypotenuse, that means we're going to use cosine. So I just come down here, let me erase some of this. And I'll label this as 40. I'll label this as bx, by components. So again, we can say that bx over 40 newtons is equal to the cosine of 35. So bx is equal to 40 newtons cosine 35. So if I take 40 times the cosine 35, I've got 32.76 or 32.77. Okay, to get this, we're going to be using the sine because it's opposite. So 40 times the sine of 35 is going to be 22.94. Again, I should be putting the units in there. I'm a little careless about that. Okay, we go to C. Again, we're going to write that in component form. When we look at C, again, if you're confused, we just do a quick sketch. Bring it over here, clone it, bring it into place. We do the same thing. We go from tail over. We go down. We will have a positive and a negative. This angle here would be 40 degrees. So I can go down this way if I want to. And this way is here. So we make this 40 degrees. Now just a trick too, remember this angle here would be 90, so you could make this 50 if you want to. If you're going to make this 50, then find this, you'll be using cosine. If you're going to be using this as 40, then this you'll be using sine. So we know the sine of 40 is equal to cosine of 50. It makes no difference which way you set these up. Just be consistent. So I'll go through this one a little faster. Just follow the same approach I followed on A and B. Again, I'll be using the 40 since that's given. So I'm going to take 42 times the sine of 40. So 42 times the sine of 40 gives me a value of 20, basically 27. And again, we come back here, is positive. Now we'll take the 42, which is right here, 42 newtons here. We're going to multiply that by the cosine of 40. So 42 times the cosine of 40. That gives me 30.64, but remember it's going down. So we go comma minus 30.64 newtons. Come to D. Okay, so we're going to find the components again. If you're confused, just keep drawing these back, because if you do this, it's almost impossible to get these things wrong. And then label what's positive and negative. This will be that'll be negative, because I'm going in this direction. The arrowhead is pointing in this direction. Arrowhead's pointing down, negative. So they're both going to be negative. So to do the horizontal, 35 cosine 55. That gives 20.08. I make that negative. Comma. I go to the y component. 35 times sine 55 minus 28.67. I'm making it negative because it's going down. Make sure I add all the units here. Alright, at this point, all you have to do is add everything up. Your new vector, we'll call it the E vector, the resulting vector, is going to be the sum of these. So we'll just start adding up. Minus 43.3 plus 32.7 plus 27 minus 20.08. That gives me a value of minus 3.68 newtons. We add this column up. 25 plus 22.94 minus 30.64 minus 28.67. That gives us minus 11.37 newtons. Alright, those are components. At that point, draw just a rough sketch of where it's going to go. I'm going to go this way, 3.68. So I'll label that as 3.68 newtons. I go straight down here. I might make this, sorry, don't make it negative, just write down the values. 11.37 newtons. Okay, my hypotenuse will go from tail to the head always. So this is E, or the resulting vector. You can make it R. At this point, we know we have a right angle, so we do Pythagorean Theorem. So we're going to do 3.68 squared plus 11.37 squared. We take the square root of that. So I'll do that. And again, you have to take the square root of that. That's going to give me E is equal to 11.95 newtons. Now to find the angle, we're going to find the reference angle first. This is theta r. So to do that, I'm going to take 11.37 divided by 3.68, take the inverse tangent. And the reason I'm doing that is because the tangent of this angle is opposite over adjacent. So 11.37 divided by 3.68, second answer gives me a reference angle of, I'll do it in black, 72.07 degrees. Now if you're confused, if the question asks you how far is that coming off the positive x-axis going counterclockwise, then think of it in this respect. If you go from here all the way back over to this line here, you've gone 180. You need to go another 72.07. So we just take that, we add it 180, and that gives me a value of write this all down, 252.07 degrees. So to write this as our final answer, okay, we can write this as E, or again, if the question asks you to write it as resulting, you do make this an R, is equal to 11.95 newtons. And again, even though these are negative, do not make the hypotenuse of the resulting vector negative. This shows you which direction it's going to go. And then you do the at symbol, and we put 252.07 degrees. Right? And that's how you add vectors together. Alright, I hope this was useful. I wish you guys the best of luck as you continue doing these.